Hey everyone, it's Jessica and welcome back to my channel. In today's video, I'm going to talk about pH testers and how I programmed this analog pH sensor from DFROBOT to use in my aquaponics system. To start off, we must answer the question, what does pH measure? pH stands for potential of hydrogen and essentially measures the concentration of hydrogen ions in a substance. The total pH scale ranges from 1 to 14. With 7 considered to be neutral. A solution with pH less than 7 is said to be acidic, while a solution with a pH greater than 7 is said to be basic or alkaline. I'm using a pH sensor for my aquaponics system to make sure that the pH of my water is at a stable and healthy level for both my plants and fish. The fish I have are small minnows, which prefer a pH level between 6.5 to 7.5. While the plants I have are different types of basil, which grow best with pH levels between 5.5 to 6.5. Ideally, this would mean my aquaponics system should have a pH of around 6.5. So this is the pH sensor I got from the DFROBOT website, which I'll link down below in the description box, along with any other resources I use in this video. The first thing in it is the pH probe. Next is a signal conversion board, as well as a sensor cable, and also some small screws and pieces which can be used to make a small stand of sorts, but which I decided not to use. And finally, there are 4 standard buffer solutions, 2 of which are pH 4, and the other 2 have a pH of 7. That's all there is in this box, but in addition to everything in there, you'll also need an Uno R3 controller board from the company Lego. In it there is a blue cable and also the board itself. Finally, the last 3 things you will need are breadboard jumper wires, Now that we have everything, we can start to put the device together. First, connect the signal conversion board to the white end of the sensor cable. Then, connect the other end of the signal board to the pH probe. After this, attach the 3 wired ends of the sensor cable to your jumper wires, which will connect to the controller board. The black wire will go to ground. The red wire will go to 5 volts. And the blue wire will go to pin A1. Finally, plug in the smaller end of the USB cable to the Uno R3. And connect the larger end to your computer, or in my case, my Mac Mini. That's all for the assembly part. I'll also insert a reference image from the DFROBOT website on how yours should look like all set up. The first thing you'll want to do is download the Arduino software onto your computer, which I've already done, but I'll leave the link to download it in the description box below. Then after I've done this, I'm going to search for my pH sensor that I found on the DFROBOT website. I have version 2 of their pH sensors, so I'm going to click on this link here, which will take me to their website. Along with the usual product description, their website also includes videos and tutorials that are very helpful. But what I want is underneath the documents header, and it's called Product Wiki. I'm going to click on this link and I'll be brought to their page, and I'm going to scroll down until I get to this sample code. Here there is a link to download their DFROBOT PH library, which you'll need for the sample code. The sample code, I'm going to copy the entire thing so that I can paste it into my Arduino program. Now I can close that tab and open up the Arduino program and paste it in. After this, I'm also going to have to connect their library by clicking on Sketch, Include Library, and Add Zip Library. And then you're going to find the DFROBOT library folder you just downloaded. I've already done this part, so as you can see here, if I go back to that same part, it will show up in my contributed library section. Now there's one more thing I need to do, and that is open up the tools section and finding the port bar, and I'm just going to make sure that it's connected to the correct part. Before we can complete this program, I'm going to quickly switch back to my pH sensor. This is what it should look like so far. Now I'm going to get it ready for testing. First, I got a small glass of distilled water and a small tissue. Next, I'm going to slowly twist the pH probe out of its little container, putting that piece safely aside and keeping it as is. So this means that don't dump out the liquid inside of it, because that's going to be needed when you store your pH sensor. So this is what the little probe head looks like, and I'm just going to put that into the glass of water and let it sit. Now that we've done this, we can go back to our program to verify it and also save it. I'm going to call this a pH sensor. Then we can finally upload it. To see your data, open up the serial monitor. This gibberish stuff will start to show up, which means we have to fix our baud rate. This program has a baud rate of 115200. However, our serial monitor is set at a 9600 baud rate. All we have to do is change the serial monitor baud rate to match the baud rate of our program. While working on the pH sensor and experimenting with the code, there were two things that I ended up having a little bit of trouble with. They were relatively easy to solve once I figured out how the program worked, but I figured I should mention them just in case they turn out to be helpful for you. The first issue I ran into was calibrating the pH levels with the buffer solutions. The website mentions how it is important to do this when it's your first time using the device, or after not using it for an extended period of time. However, the instructions the website gave me didn't work, and nothing showed up when I tried typing the commands enter, cal, or exit. To solve this, I had to go to the DFROBOT library's C++ file. After searching up the keywords, I found out that the commands required to calibrate were called enter pH, cal pH, and exit pH. With this new information, I could then correctly calibrate the 4.0 and 7.0 solutions. The second issue I had was what I'm going to call trash or garbage data. One of the things I wanted to do was put the pH level data I collected into a graph, which is something Arduino can do with Serial Plotter. But I kept noticing that at the beginning of every plot, data was very random. To graph my data, I had to get rid of anything that wasn't a number. However, even after commenting out all of my writing, I discovered that there were still 2 lines that kept popping up whenever I first uploaded my data. After some experimenting, I realized that the writing must come from pH begin, because when I commented that line out, the writing no longer appeared. This seemed to have solved my problem, but because I didn't know what else pH.begin affected, I once again went to the C++ file of the DFROBOT library. There, I found the writing under the begin function and commented them out. I also left a note that this was edited by me in case I wanted to change it in the future. Then, all I had to do was save the file and rerun the program. Now, only numbers were output to my serial monitor, and my serial plotter could work correctly. I hope this was helpful. Thank you so much for watching. If you enjoyed this video, don't forget to like, comment, and subscribe to see more videos from me in the future. Bye!